Good morning, everyone, and welcome to the IFCYBER Seminar series. Today we have Killian Sexsmith, who is a senior developer relations manager at NVIDIA, and he's probably looking at Morpheus product. Given that cybersecurity has dominated the Australian landscape in last couple of weeks with all these different types of attacks, hopefully we'll get some good insights from his talk. So he's previously led a team in data science and edge practice in public sector at Red Hat. His focus is now on building AI into cybersecurity practices across the globe by accelerating the ability of organizations to analyze critical data using AI with Morpheus. So that's a very quick introduction. I'm sure Killian can add a bit more himself. For Q&A, I think we'll wait to finish until Killian has done his talk. But please keep typing your Q&A in the Q&A section. And also there is a button called live button, Killian tells me, that you can click if you want to grab Killian's attention to answer on the fly. At the end, probably we'll also have more interactive session where you could speak on the microphone if you wanted to. So I think probably time for us to get started. We've got about 12 attendees. Hopefully some more people will join.
All right, thank you, Sanjay. Appreciate it. And thanks everybody for your time today. As Sanjay mentioned, Killian Sexsmith, based in Austin, Texas. I've actually, I used to travel globally and spent quite a bit of time in Australia. I quite like it. So I hope everybody is enjoying what Australia has to offer. It's probably better than Texas. Kicking off here, my role with NVIDIA, I've been with NVIDIA for about 8 months. As Sanjay mentioned, I come from a background at Red Hat with leading a data science and edge team. Since I've been at NVIDIA, you know, it's a completely different culture. It's extremely fast paced. Everybody is going 1,000,000 miles an hour with their projects, which I'm sure everybody on this line can relate to. So yeah, it's definitely been an experience. What we're doing in the cybersecurity realm is pretty unique in the sense of I've traditionally only been working with products and with customers, but what we're doing with Morpheus, I mean, it is an SDK. So our approach with cybersecurity really starts with this idea that cybersecurity is effectively a data problem. We look at the average days to identify a breach at 287. The average cost per breach is obviously quite high. We have a number of challenges: high velocity data streams, heterogeneous data, integrating across complex environments. It becomes very difficult for SOC analysts to quickly iterate and pivot and be able to quickly ascertain what is a critical alert, what is something they need to look into, and what is background noise. I'm sure everybody is very aware of these challenges. So what NVIDIA really does here is, you know, we're providing the ability to analyze this data in real time. We leverage GPUs, obviously, we're a GPU-based company, and we believe that we're uniquely positioned to be able to analyze all of this data, you know, using models that either we develop or are developed within the ecosystem to process all of that data extremely rapidly, basically filter out the signal from the noise and get the salient data to those SOC analysts in order for them to do their job better. So some of the challenges, again, I know I'm talking to a cybersecurity group here, so just bear with me, but some of the challenges that we're facing in the industry, you know, a shortage of professionals. I saw a report the other day, something like over 50% of cybersecurity professionals are looking for a change in career simply because they are overworked. They don't have the support or the tools that they need to do their job properly was the primary reason that they gave. Difficult deployments. There are a ton of options on where we're going to, where you can deploy workloads, how you're going to deploy them. Obviously, cloud native deployments are extremely popular. We still have to deal with, you know, traditional deployments on bare metal, deployments via VMs, cloud-based deployments, SaaS offerings, et cetera, et cetera. It becomes very difficult to kind of wrap your arms around all of that and ensure that you understand where your data is sitting and how it's being utilized. The one on the bottom left is probably the most salient around log collection really outpacing analysis. Something like 80% of all data being accumulated by an enterprise is left unanalyzed. So this is, obviously problematic for, one of those earlier stats around 274 days before we can identify a breach. That's largely because this data is sitting there just waiting for somebody, a SOC analyst or an analyst of some sort, to go and start poking it to see what went wrong and when. And that usually only happens after a breach. So in order to kind of turn that on its head, we're advocating, the live analysis of data via AI models to give those SOC analysts and cybersecurity professionals a leg up in finding a breach early and triaging it as fast as possible. Lastly, model complexity. Obviously, there's a ton of work being done in the AI space right now, managing AI models, keeping track of even just basic version control, what that model is doing, what the test data what test data it was trained on. That in itself is a full-time job. So one of the kind of tertiary challenges that we're seeing is that the cybersecurity focused developers don't typically have a relationship with a data scientist in the organization. So we see this tool as being a mechanism by which to bring those teams together and, kind of like the DevOps movement and whatever kicked off in like 2010, bringing developers and operations teams together. We have to do the same thing with cybersecurity professionals and data scientists. So looking at the modern data center challenges, kind of what I alluded to earlier with microservices, this really does contribute to a lot more east-west traffic within an organization. And zero trust is an extremely popular phrase. It's an extremely popular approach to doing security. It's actually been mandated, at least in the US, by the president himself, basically telling the agencies that they need to have a zero trust architecture and strategy within their respective orgs. And really what this means is rather than looking at perimeter security, we need to constantly be verifying that the people are who they say they are, that they are only accessing the resources that they should be accessing, and so on and so forth. So just continuous authentication, continuous monitoring throughout the environment. So let's get into what Morpheus is. Like I said at the outset, it's an SDK. It's a type of framework. It is not a product. We are not trying to compete on the open market against other cybersecurity vendors. We are nowhere near as feature-rich as a number of products on the market today, but we do believe that we provide unique value. So going up the stack here, building on top of our accelerated servers based on NVIDIA GPUs, Morpheus itself requires Pascal or a later version of GPU, which is, like 3 architectures ago. So pretty much we work on pretty much everything that is in operation today. We also integrate fairly well with the DPU, which is a data processing unit or a SmartNIC. It's another piece of hardware that NVIDIA provides. Going up the stack, we have a number of libraries and that we leverage, such as Rapids and CyberLog Accelerator. We actually ship with Triton Inference Server, which, as you can imagine, is for inferencing. And we also provide a TensorRT as well. So Morpheus itself, we can think of as an abstraction layer almost on top of this, where we're providing a pipeline to perform the pre-processing to inference to post-processing and action stages on all of the data that's coming in from the left-hand side of the slide here. We're fundamentally data agnostic. You can see these sources, SIM, source, app logs, cloud logs, the Bluefield Converge card. Basically, any way you can get your data into Morpheus, we're able to build that into the pipeline, massage that data into the appropriate format, and provide analysis and value on top of it. So, don't think that we're only explicitly focused on, logs or L7 payloads or anything like that. We're very flexible in how we bring that data in. It's just a matter of getting that data into the right format, ensuring we understand the shape of it, and moving it into the pipeline. One of the advantages of the Morpheus pipeline, I'll talk about this as we go, but think about it in reusable stages, right? So we've constructed this pipeline with the idea that they are, fundamentally agnostic and modular. This makes it easier for developers and cybersecurity professionals to effectively take parts of that pipeline and stitch them together in new and unique ways. So each one of these parts of the pipeline, we'll get into this, but we call them the stages. Each one of these can basically be mixed and matched, and we are able to then have a very versatile solution that actually minimizes the amount of programming that actually has to be done. So think, again, like a simplification of an abstraction for some of the complexities in the underlying libraries and frameworks. We make it simple with a very easy to use CLI as well as a Python interface. So we do ship with a number of use cases. We can think about these as more or less kind of example use cases that are absolutely valuable in their own right, but we're trying to avoid saying that all of these models are absolutely perfect as is. There's obviously a lot of work that has to be done ongoing to keep a model current. So what we do is we ship with these use cases with some models with the intent for the customer, the user, to continue to build using their own data on these models, and basically increase the value of the entire pipeline, the entire framework via that type of upkeep. So going over them really quick here, digital fingerprinting is probably our most popular use case. In this one, we'll dig into the technical details in a second here, but at a high level, we are leveraging autoencoders. So think unsupervised learning in order to create a very lightweight model on a per user, per machine basis. What this enables us to do is effectively look for anti-patterns. So if everyone's kind of familiar with the idea of like UEBAs, user and entity behavior analytics, that usually takes, almost like a macro approach to a lot of this. We're looking at it extremely granularly on a per user, per machine basis. So as a user, if I log into 3 of my corporate systems a day, and I'm always logged in from this GeoIP, and I'm always using the current system that I'm on, the OS, then that builds into the profile. If suddenly I start logging in from Mexico and I'm accessing 50 corporate systems a day and it's in a completely different OS, then it's obviously going to set off an alert. So it's less to do with kind of the macro policies of what people can access and more to do with identifying anti-patterns within what that user or machine is doing. I'm going to go through the rest of these relatively quickly because most of them are kind of like self-explanatory. Like everyone's familiar with phishing detection. We're using natural language models to analyze a full body of emails in this instance. Leak sensitive information, we're again using NLP in order to identify leaked credit cards, keys, bank account numbers, that type of thing. Trained on, I believe, 2 million synthetic logs in order to get that output. Anomalous behavior profiling. Here, there's actually 2 paths to value. One is integrating directly with the GPU. So we're able to detect a profile on the GPU of any sort of crypto mining activity that might be happening. Is probably less relevant than it was 6 months ago, but still. We also integrate with the DPU, in this case, an app that we actually have called App Shield, which takes snapshots of memory to look for any sort of suspicious activity. We effectively, profile what malware or any sort of malicious code acting on the memory estate is, and we're able to identify that using ML. And then lastly, identity fraud, where we're using graph neural networks, which is an exciting area of research for us. This one is still in early access, but the overall idea here is that we are looking less at just the transaction and more at the correlated behavior across a wide graph. So if we think about like a user and a vendor, and they may have a transaction, we're able to look at any sort of lateral movement that is taking place across that graph to see if we can correlate activity with potentially a coordinated attack that may be occurring. Again, this one is still very early on, but we see a ton of potential growth in using GNNs in general and specifically with regard to cybersecurity. So here's another view on the use cases. Again, we fully support and encourage our customers, our users to bring their own models and kind of get creative with the use cases that they can bring. The fundamental value of Morpheus really is that data pipelining and our ability to process vast amounts of data very fast. Some of the top ones are the ones I went over. Some of the bottom ones here are kind of our applied R&D, where our data scientists and engineers are currently focused on things like ransomware detection, predictive maintenance, root cause analysis, obviously particularly relevant in the industrial space, DGA detection, LODA, generic lightweight anomaly detection, and cloud native abuse detection. These are just some of the areas where we're exploring to see if we have value to the ecosystem in the models that we're creating and the pipelines that we're creating. So, you might see these change over time. You'll almost certainly see them change over time, but just to kind of give a sense of where we're going from a research and development standpoint. This is another view, and the reason why I'm highlighting this one, it might seem a little redundant, but just to kind of highlight the data source, like where we're actually pulling data from. So you can see we're going from everything from L7 data to GPU, CPU statistics, email collection, AppShield, that application that I mentioned on the Bluefield 2, authorization logs, and so on and so forth. Probably most of the activity is really in the log space. Most kind of breaches and nefarious activity is alerted in the context of logs in one way or another. So that's really why digital fingerprinting has shown value to customers in the early phase. And by the way, this is actually a pretty new effort. We came to market with this, I believe we went GA in May. So it's still very, new to the ecosystem, new to NVIDIA, but we're seeing a tremendous amount of interest in this from our partners, from our ecosystem partners. And kind of to take a step back specifically from the use cases here, our kind of approach is, we absolutely want to integrate with other ISVs. We want to integrate with other products on the market. We also see a vector to add value with the GSIs, the global systems integrators, people that are looking to differentiate their own offering in the ecosystem by leveraging artificial intelligence in this way. And then finally, we try to provide value to the customers, ultimately the end users. But really, the target demographic, the people that are going to find this the most useful are the developers focused on cybersecurity and the data scientists. Again, bringing those two groups together is kind of one of our tertiary goals. So these sample workflows, not all about NLP, kind of like I broke down, some of it is the sensitive information phishing detection, very much an NLP based problem space. We're also leveraging decision forests, autoencoders, and graph neural networks, depending on the use case. The point here really is just the flexibility of Morpheus to be able to, not only accommodate these models, but the variety of data feeds coming into it and still provide value in the form of, both developer velocity and data processing speed. So with regard to speed, some of our early outcomes with customers, we saw substantial speed up from a SIMRank perspective, as well as a domain generating algorithm detection speed. We saw over 200x speed up with one of our early access partners. But the most kind of important salient point here is the code reduction. We went from over 2,000 lines of code to 136 in a real world customer scenario. So again, by using these like reusable pipeline components, we're actually able to dramatically simplify what a lot of customers have already started to build by hand. So don't think of it so much as we're adding a ton of work or complexity necessarily to the system. Think of it more like we're actually providing a framework, a reusable framework that will minimize the amount of work that has to be done. So one of the top questions that I typically get in any one of these is actually, well, why would I use GPUs? I can already do CPU-based inferencing. You know, it may not be as efficient, but GPUs are expensive. So just to kind of put that into perspective, on the left-hand side, we're looking at the data size. We're then looking at the processing time for CPUs and GPUs respectively, and the speed up factor across each of those, as you can see, grows with the more data that we throw at it. We did some cost comparison. This is based in Google Cloud around how much it costs to run the GPU and CPU costs and the amount of savings that you get, and just purely based on the data throughput and how long it takes to churn through it. So while this is focused on Spark data frame performance, the same kind of rules and benefits apply when using Morpheus. We just haven't explicitly benchmarked it for the product yet, but it's definitely one of our near-term goals to get those numbers specifically with Morpheus. So let's get into some of the technical details. Pardon me, I've been talking all day and my throat is super dry, so I hope you're forgetting the sips of water. It's 5:30 p.m. for me, and it's been a long day. So digital fingerprinting, we're looking for credential attacks, compromised credentials, exposed credentials, et cetera, et cetera. Most attacks actually start this way. So this is a common vector to compromise those credentials and get into a system. Candidly, you may have heard that NVIDIA was compromised in February of this year. So that's no secret. It was, obviously something that we're not proud of. And, Morpheus was not in play at that time. We have since, I have slides that talk about this in a little bit, but we have since used Morpheus retroactively to look at the logs during that time period to determine, hey, could we have detected the attack earlier? And the answer is absolutely yes. We would have actually got a week's head start in identifying that the nefarious activity of the attacker had we been using Morpheus at the time. Of course, it was still in early access. It was not GA at that time. So it's just a poor timing as opposed to any other reason. Like I said, after the fact, we have actually implemented this. We're using this in production at NVIDIA across all of our 25,000 users. And I'll speak more to that in a second. So for digital fingerprinting here, kind of what I alluded to, we're pulling in the log data and looking at individual models on a per user and per machine basis to detect anomalies. Morpheus kind of sits in the middle in the general ecosystem, right? We have our sources, we have our sinks, and we have Morpheus doing that data processing with models on top. So we'll see a lot of integration points with common SIMs and source, such as Splunk or Elastic, even Redis. These types of integrations are quite common. I see something popped up in the chat, so okay, there we go. So real world scenario, this is actually our data from the time of the attack. As you can see, going through December, January, and February. Just to kind of orient you, if we're looking at the left-hand side, the left-hand axis, the raw Duo events are measuring in the thousands. Cisco Duo, our security solution. And then DFP, digital fingerprinting alerts on the right-hand side, measured in the tens. That dotted black line is really kind of what we're saying is the level of not a strict threshold, but kind of the manageability level, right, of what our SOC analysts would ideally like to be able to address. So anything more than 10, 12, 15 alerts, it ends up becoming more like background noise. So from a usability standpoint, that is kind of what we're targeting. So you can see that we take like those thousands of events and boil them down into a very manageable set of digital fingerprinting alerts. You'll notice that this was actually the attack day where the alerts kind of went off the scale. But we had some preamble to that, which is actually identified here. So this is the day where everything kind of hit the fan. And this is actually what our digital fingerprinting models had picked up. So you can see the max anomaly score. We would have picked up the nefarious activity about a week before we did, and the week before they made themselves very well known on our network. So just a real world example. Like I said, we're using this in production today, which is great. We built out this architecture to highlight, what we did specifically for this use case with our IT and our SecOps teams. So, it's relatively straightforward. We can look at the training pipeline on the top, inferencing pipeline on the bottom, our S3 sources housing the Azure AD and Duo 2FA logs on the left, feeding into each of them. We have HashiCorp Vault and Databricks in the middle, hosting MLflow model repository, and ultimately pumping out results to an S3 bucket in AWS, which then go to Splunk or the digital fingerprinting dashboard itself. You can see it's going through these steps, kind of those modular steps I was mentioning earlier as part of the Morpheus pipeline. And the way we're kind of breaking this up from an assignment of duties, if you will, is corporate IT on the left-hand side is very well capable of aggregating those logs, providing the log source. SecOps is most interested on the right-hand side of looking basically at a SOC, at the dashboards that give them clear insight into what's going on. And then the systems integrator usually facilitates this role, but this can easily be taken on by a variety of teams. This is essentially just making sure that Morpheus is integrated on both the sink and the source site, as well as the credentials and model repository. We're not saying that it absolutely has to be deployed this way. We just have an opinionated architecture that we're actually using internally and wanted to, kind of contribute it back to the community so people saw how we were doing it. If we wanted to switch any of these elements out, if instead of Splunk you wanted to use Elastic or you wanted to put Redis into place or what have you, that's absolutely possible. We're actually in active development and writing some of the integrations with alternate vendors in this way to simplify that type of work. But really the true kind of goal here is that this is all open source. So we would love the community involvement in order to, kind of build out what's next. We're working hard on what we think the community needs, but if there are specific needs that aren't being addressed, going on GitHub and raising those as an issue or actually contributing code is obviously very much encouraged. Open source only really works if people are contributing. So yeah, that's kind of our vision for how this will mature over time. Going into kind of the data science layer for digital fingerprinting, there's actually two things going on. We are using autoencoders, like we mentioned. We're also using some temporal models, effectively looking at fast Fourier transforms and inverted fast Fourier transforms to map out the time series data. So we can think about reconciling these two outputs of models in the inference stage and looking at the behavioral anomalies that relate and correlating those to specific behavior. So that's just kind of like the next layer down on how this all really functions. What we have noticed in a lot of our testing is that we're actually just as accurate using autoencoders solely without the temporal models. So we may end up deprioritizing the latter in the near future. Oops. Okay, moving on to phishing detection. And by the way, feel free to add any questions or comments in the Q&A box. I have that pulled up on my alternate monitor, so I can kind of try to address those live. At phishing detection is a pretty straightforward use case, pretty straightforward attack vector. Everybody is likely very much aware of it, but we still are faced with this problem every day. So what are we doing that is fundamentally different, or why did we decide to work on this? Because we're actually we believe that we are adding some unique value here in our application of natural language processing to the full body of the email. So we effectively, do pre-processing on all of this text, wrap it up in a sequence classifier, which clicks CyberLog Accelerator, kind of does for us, trains up a DNN. We convert that model to TensorRT, and then we load up that model for inference. As you can see on the bottom, our F1 scores are pretty good, and these are actually a little old. I believe this is from our early access 2 version, and we have only improved since then. So we are seeing this in use in a couple of major vendors and retail. And they've got fantastic results from it, and are moving on to other use cases and building those out. So that's just kind of a quick view into like two of our more popular use cases. Very happy to go into the others. We can talk about leveraging GNNs, graph neural networks, but figure kind of to stay on track and keep moving here. Focusing on the underpinnings of what Morpheus is. The models are great, but there's a lot of models out there. Everybody can kind of create their own, and we're hoping to, grow that aspect of the ecosystem by way of Morpheus. But the not secret sauce is not the right word. The fundamentals of Morpheus are really built on this adaptive pipeline, right? So we use a reactive framework that underpins Morpheus. This is great for things like back pressure, allocating fibers to the appropriate resources, stealing resources from underutilized processes, and basically adapting to the variability in the cybersecurity data streams. This really is what makes Morpheus fly when it comes to performance. So we'll go into kind of the anatomy of a pipeline and what this means in a second. But again, calling back to that earlier metric, that 2,000 lines of code to 136, that's based, primarily on this this type of approach with the reactive framework. Just saw a question come in. So before I dive into the pipeline, I'll see if I can address this one. The question is, I was wondering if there are any plans to roll this out to users of consumer grade GPUs, either to help secure those end users or to collect a wide range of compromised data, or is this intended only to be used in enterprises? That's a good question. So we actually work on any GPU, Pascal, and later. So the most common one tends to be the T4. We don't see much. We think it's probably too much, like we don't have in our sights looking at actually running on endpoints themselves. We would instead operate at the aggregation layer. So where all of those data points feed into the data center, into corporate IT itself, that's where we would function, is at that aggregation point. I hope that answers your question. So yeah, we're not really targeting running on desktops. It's just not really applicable. But that said, we do see a tremendous amount of value in edge deployments. So a lot of our early activity and early wins, actually, I spoke about this at my GTC session just this past September. But we highlighted a lot of our partner work in the edge space, and some of the use cases are largely around, creating these portable systems that can go to edge locations, and they're effectively the sanitized cybersecurity system, right? So think about like a potentially compromised edge location. It's really important for the people trying to rectify that situation to go in with something that they're confident is, secure and basically hasn't been compromised in any way. So they're calling these flyaway kits. And right now, Booz Allen Hamilton and IntelliGenesis both have offerings in this space. So yeah, we see a lot of the OT, the edge use cases, but yeah, we're not tackling the running this specifically on user endpoints. Okay, I hope that answered your question. Thank you. Moving on, yes, leveraging back pressure, reactive programming, fibers, etc. This is really what makes Morpheus as performant as it is. So let's dig into pipelines. This is a sensitive information detection workflow, but it's really more, the point of the slide is really to look at the various stages: input, pre-processing, inference, post-processing, and output, kind of what we highlighted earlier. Taking the next step down, we can see this as the slide builds out. The difference between the prototyping stage, which is highlighted up here, reading file, like basically reading from file, getting instant feedback on the throughput, writing a result to a file. Like this is the prototyping stage, right? In order to change that to production, it's very simple to swap out the stage itself. So we go from file to from Kafka, which is basically a bus of sorts, and then to Kafka as an output. So, think about this as like, instead of having to rewrite the entire thing or, potentially just spend a lot of time doing something like that, we've already created these stages and make it easy to plug into the sources and the sinks. Similarly, we can swap out, the monitoring stage isn't as important in prod. We've already verified that we have the appropriate throughput. So we can just move the post-processing stage over and look more at the ML flow metrics to gauge any sort of concept drift on the models themselves. So really it's maintaining the core processing stages between these two, only swapping out the stages that are necessary in order to fulfill the use case in either prod or prototyping, and then basically iterating on that type of development very quickly. Here's another view just to kind of highlight the reusability of these stages in either C++ or Python. We've actually, this is worth kind of going on a bit of a tangent on, like a lot of this reactive framework, a lot of what underpins this is written in C++ for performance reasons, but we've abstracted a lot of that functionality into Python just from a usability standpoint to make it easier for folks to operate. So things like log aggregation at each level for each language, we've simplified that and unified the logs. So you're not having to constantly jump between log locations, that type of usability stuff. Support for multi-GPU acceleration, refined APIs, et cetera, et cetera. Like these are all the benefits, but really to highlight here, this is what I just showed on the last slide from a pipeline perspective. But when we kind of build that out across use cases, it starts to look more and more like this. So you see a lot of commonality amongst, whether it's sensitive information detection, anomalous behavior profiling, phishing, HAMA, which is digital fingerprinting, it's human as machine, machine as human. Anomalous behavior profiling, again, using PCAP data, graph neural networks, et cetera, et cetera. You'll see a lot of commonality between these stages, right? So it becomes a fairly compelling argument to leverage a framework like this, as opposed to writing these unique kind of pipelines that are, not that portable between use cases. Okay, this is second to last slide, and then we can, turn this more into a conversation if it makes sense. This is how we integrate with the Bluefield DPU. Again, the DPU is a SmartNIC. It's a data processing unit. We are taking the real-time telemetry from these DPUs and piping them into Morpheus. What this does is it enables a feedback loop to occur, right? So we're basically pulling that telemetry and performing our analysis, assigning, leveraging AI to get a result, and then turning that into a security policy that we push back to the DPU. For those that aren't familiar with how DPUs kind of function, they largely are, they're becoming more and more popular because there is a way to offload infrastructure-based services from a server onto the SmartNIC itself, right? So instead of taking up valuable resources on the server, we just offload a lot of that stuff to the DPU. So as all of the data comes in, we pipe that over, pull a security policy back, and we're able to have effectively penalty-free visibility into some complex environments. Usually microsegmentation is in play when DPUs are in use. All right, last slide. So again, NVIDIA Morpheus is an SDK, it's a framework. We're not trying to be a competitor in the industry, in the cybersecurity industry. We're hoping to grow the ecosystem and contribute back all of the wonderful IP that our engineers have created. We have tremendous speed up over CPU-based alternatives, tens of millions of models in real time. And we're constantly creating these new use cases and providing them out for free. It is open source. Check it out in GitHub. We also offer something called Launchpad Labs. If you haven't heard of Launchpad, it's a program that we have that is free. You can go and sign up if you just Google like NVIDIA Morpheus Launchpad. I can provide the link, of course. You can go and sign up. You get one of these labs for 2 weeks by default. It has all of the labs, all of the use cases in lab format that I just kind of highlighted here in the form of Jupyter notebooks. You can run through those. It's internet accessible. So if you wanted to pull down code from your own GitHub repo or push code to it, that's completely fine. They're deployed on bare metal Equinox systems globally. So there's some in your region. Yeah, it's just we'd love to have your feedback on what you think. So please, by all means, check that out. Sign up. An environment is all automated, so an environment will be proficient to you within a couple of hours, if not less, and away you go.
All right. Yeah. So Killian, I think probably we'll start to take some Q&A. Thank you very much for a very interesting talk. Everything you have said is extremely important. I don't know whether you followed the news, but Australia has gone through massive cybersecurity attacks in last 3 weeks, and a lot of credential identity theft. So everything that you have presented there is becoming more and more important. While my colleagues are thinking about questions, my question to you is that, like, you're talking about analyzing logs, logging attempts and all that. What is it that your platform presents that was not possible before, and how much is it used by the industry?
Yeah, great question. So our differentiation in the market is really around the speed with which we can process data. The models that we are creating and contributing back to the community, we believe that they are unique, they are differentiated. What we're doing with autoencoders is pretty unique to cybersecurity use cases, or at least we haven't seen anybody else really doing it that way. Taking a step back from that specifically, we're just seeing the growth now of applying AI to cybersecurity issues. Over the last couple of years, like not just right now, but over the last couple of years, this is becoming more and more common. Where we fit within the broader industry and where our uptake has been, we have worked with a lot of early adopters in the ISV market. Frankly, it's a lot easier to make inroads with ISVs and software vendors when they're on the relatively small to medium size. Very difficult to convince larger ISVs to fundamentally alter their core product on something that's relatively new. But our goal is to have a compelling enough story and have enough people kind of wanting and pushing for this to be the way forward, that we are able to make those inroads. And I might be underplaying it a little because we actually do have some pretty large vendors that have come and spoke at our events, like Splunk. They're doing a ton of great work leveraging Morpheus actually for a co-pilot use case. So using our NLP models to translate SPL into or regular English into SPL, their query language. So they've spoken a couple of times at GTC and at their own conference about that project. And for them, they're actually using Morpheus not only for the NLP piece, but also to identify the sensitive information that may unintentionally be leaked as part of those types of queries. So yeah, a lot of interest in the ISV space. Again, still very kind of like, and we're in a nascent mode. But we are seeing a ton of activity also in the GSI space, right? So the systems integrators, they see this as kind of an easy way to differentiate by leveraging AI and cybersecurity. There's not a ton of people doing that right now. So it's easy for them to get, some fairly significant wins with relative, they don't necessarily need like a massive team to be building and maintaining all of these models. I just need, a data scientist and a cybersecurity developer to be on the same page, and they can kind of, iterate on what we're providing and add a ton of value.
Thank you so much. I think we have a question from Tom Townsend. It's a very long one. Do you want to speak, Tom? Gillian, could you enable the microphone for all attendees as well so they can ask a question?
That was to Gillian, right?
Sorry, we had this confusion with G and K even in chat. So yes, that was. But you could read the question yourself, and if you have a quick glance. But
yeah, absolutely. I'll just read it out loud. From Tom, it occurs to me that the output of your approach to granular per user profiling and anomaly flagging has utility from an IT ops perspective in terms of personalized user support or identification of intermittent or tricky systemic issues. Is this what you meant earlier by predictive maintenance? Does your output get used, consumed outside cybersecurity use cases? That's a great question. Yeah, that's exactly what we're talking about. So, you know, the fundamentals of Morpheus, while it is geared to be a cybersecurity solution, are completely usable for you know, kind of the tertiary use cases like this. So, you know, a lot of our interest, particularly for things like predictive maintenance, is identifying patterns when, you know, certain logs start to appear with, you know, not necessarily cybersecurity logs, but, you know, logs for various machines operating. You know, if you start to see this log pop up, you know, you can easily kind of correlate that to a potential failure. Right. So that's part of the, you know, we're just now kind of like, you know, turning our sights to it. It's not well developed on our part at all. But to your point, this is absolutely, you know, very much in the realm of not only possibility, but, you know, concrete goals from our engineering and applied R&D teams.
All right. Do we have any more questions? No, so I guess a lot of our PhD students are pretty much using the GPUs. They're working on the kind of things that you mentioned at the intersection of AI and cybersecurity and looking at various models. With models, sometimes like in research paper, we see it's very hard to replicate the results. So are you also providing data to verify your models?
Yeah, everything is open source. So the like all of the data sources that we've trained on are publicly available, which is, you know, it's great, but it's also like, you know, as everybody's very well aware, right? Like the models are only as good as the data, which is why we provide the training and tweaking scripts, so customers are able to, you know, kind of personalize what we've built based on their own data. So there's really no way of getting around the fact that you require somebody who knows the data. That's just kind of true for anything data science related, in my opinion. But yeah, so we provide these training and tuning scripts to, you know, personalize based on actual customer data. And again, we highly encourage our users to bring their own models. So once you kind of like, you know, wrap your arms around what the pipeline is doing and what the advantages are, we would love to hear from your PhD candidates, your students, faculty, whoever. You know, if you see a compelling way for this to be applied in something that requires a substantial amount of data throughput, we would love to hear it. And I'm literally the person that you would probably want to talk to in order to get that request through. So.
It's nice. We look forward to doing that. And looks like we don't have any more, do we? No, we don't have any more questions.
Yeah, Tom had another question. You mentioned detection of crypto mining. There's some recent articles relating to the super efficient, to how efficient your new GPUs are at brute forcing passwords. Yeah. Is that something you will be able to look for and detect? That's a really good idea. We haven't actually thought about that, but yeah, I'm actually going to bring that up. Great idea, Tom.
All right, so I guess like we had a fairly good conversation here, and probably we will be able to reach out to you in future if we need, and I'm sure we will. So thank you so much for very interesting talk, and hope you have a relaxing evening and just rest your throat with your favorite drink. Thank you, everyone.
Thank you.
Thank you, everyone, for coming along, and look forward to seeing everyone in our next talk. Bye.
Thanks all.